Today we'll be learning about John Dalton. Now, to begin with, let's learn about some of the early life surrounding John. He was born in Eaglesfield in the United Kingdom in 1766 on the 6th of September. That was more than 250 years ago. John had a younger brother who shared a very interesting feature that John also had. John found out that they saw colours different to everybody else, later seeing that they were both colourblind. We believe that John could not see the colour red very well, or tell the difference between orange, yellow and green. Another fun fact about John was that he was a school teacher at the age of just 12 and became the principal when he was 19. He's only a few years older than you guys, and he was already teaching some classes. John Dalton was not only a teacher, he did several other things. He was a meteorologist, chemist and physicist, which means he did lots of experiments. Through all these experiments, he started to pull apart the things we're going to learn about today, the atomic theory. Dalton discovered 5 main points about the atomic theory. These were: elements are made of small particles, they cannot be subdivided, created or destroyed, chemical reactions combine, separate or rearrange atoms, atoms of the same elements are equal in size, and atoms of different elements combine to make chemical compounds. One thing John Dalton solved was how atoms create objects. So, the first thing we need to know about atoms is that they are always moving, but more or less depending on the formation that they are taking on. After looking into John Dalton's research, it suggests that each atom has its own kind of energy, which we can see from these photos. The brick, water, and gas all have the atoms that make each object beneath them. So, what can we take away from this photo, guys? Exactly! The solid atoms are close together, and as they turn into liquid and gas, they move further and further apart. Perfect, good job guys. So, if you guys understand how that works, let's look at an example such as water. So, the warmer the water gets, the faster the atoms move, or the colder the atom gets, the slower they move. So, by looking at the example on the board, which form of water would have the fastest atoms? Yes, correct, the cloudy gas. Now, which one would have the molecules move the least? Yes, the ice, which means the running water would have the atoms that move around a little bit more than the solids, but a little bit less than the gas. Really good work today, guys. Now, I'm going to teach you guys a little trick to remember which formation has which structure. I want you guys to imagine that you guys are atoms. So, for a solid object, I want you guys to imagine you were sitting down nice and still in the hall, not moving very much like the atoms in a solid would. Now, for liquids, let's imagine the bell just rang and you were leaving the school hall, but you were still in your lines that you sat down in. You guys are moving a little bit, but nothing too crazy. And then for gases, imagine the school bell just rang, it's home time, and everyone is running as fast as they can, zipping and zooming around. Alright, great job today guys, see you after lunch.